Hello, yes, and welcome to our Unit 5 practice exam. So, as per usual, I've taken a stab at what type of questions I think might be on the unit exam, and today I'm just going to go through them together. Hopefully, you've already completed this exam. That's really what this is for. This is for you to grade your work. So, if you haven't completed the unit exam, go ahead and do that first. There's a blank copy on the Teams page. Go ahead and do that. But if you have, then let's go ahead and go through. Let's see how we did. Kind of grade our own work, make sure we're good. So looking at number 1 here, 4x squared minus 2y squared is 18. 8x squared plus 10y squared is 50. A nonlinear system. All of the variables have the same degree though, so we can go ahead and use a matrix here. So at a 4, negative 2, 18, 8, 10, 50. And then RREF. So I'll go to second, matrix, edit. This is a 2 by 3, 4, negative 2, 18, 8, 10, 50. There we go, second quit. Second matrix, go to math, RREF. Second matrix A, close the parentheses. 1, 0, 5, 0, 1, 1. Alright, so 1, 5, 0. So remember, since this is nonlinear, this is what x squared and y squared equals. So we found that x squared equals 5 and y squared equals 1. When I take the square roots of that, that means x equals plus or minus the square root of 5. Y equals plus or minus the square root of 1, which is just 1. And now I need every possible combination. So this will have 4 solutions. Those solutions are going to be the square root of 5, comma 1. Then we will have the square root of 5, comma negative 1. Then we will have negative square root of 5, comma 1. And the negative square root of 5, comma negative 1. And there are our 4 solutions to this system. Excellent. Let's look at number 2. Alright, 2, we got a 3 by 4 matrix here, so let's go ahead and start by putting this as an augmented. So 3, negative 1, 5, 22, negative 1, 4, negative 2, negative 26, 6, 3, negative 7, and 2. Alright, and then we will RREF. Let's make that a little bit bigger so I have more space to write. Let's see what we get here. So second matrix, go over to edit. Now we have a 3 by 4 matrix. So 3, negative 1, 5, 22, negative 1, 4, negative 2, and negative 26. And 6, 3, negative 7, and 2. Okay, second quit. Second RREF matrix A. Alright, so this one's going to have one solution. 1, 0, 0, 4, 0, 1, 0, negative 5, 0, 0, 1, 1. So this tells me x is 4, y is negative 5, z is 1. So my coordinate would be 4, comma, negative 5, comma, 1, 1. Remember, it's x, comma, y, comma, z for that one. We know there's one solution because of our bottom row. Remember, if this bottom row is all zeros, it's infinite. If it's all zeros and then a constant of 1, then that's when no solutions occurs. All right, number 3, another 3 by 4. Okay. So let's go ahead and make our augmented matrix here. So we have negative 1, 2, 3, 4. Nice. 9, negative 12, negative 6, negative 21, 4, negative 4, 2, and negative 6. Alright, and RREF. Let's put this one into the calculator. So second matrix, got to go over to edit. Again, matrix 3 by 4, negative 1, 2, 3, 4. I like that row. 9, negative 12, negative 6, negative 21, 4, negative 4, 2, negative 6. Second quit. And let's RREF. Okay, so notice here, got a bottom row that's all zeros, so that tells me this is going to be infinite solution. I get some decimals, so let's go ahead and math frac. So we have 1, 0, 4, 1. Oh, what have I done? 1, 0, 4, 1, 0, 1, 7 halves, and 5 halves, and 0, 0, 0, 0. So we have infinite solutions. However, remember, we cannot just stop and say infinite solutions. We need to solve this in terms of A. So let's write the equations that we have here. So we have x plus 4z equals 1, y plus 7 halves of z equals 5 halves. And then we say let z equal A. So we will have x plus 4a equals 1, and y plus 7 halves a equals 5 halves. So we'll subtract 4a, so x will equal negative 4a plus 1. We'll subtract the 7 halves a, so y will equal negative 7 halves a plus 5 halves. And then we'll write our coordinate pair where x is this value, y is this value, and z, of course, is a. So that would be parentheses, negative 4a plus 1, comma, negative 7 halves a plus 5 halves, comma, a. And there we go. B-E-A-U-T-I-F-U-L. Beautiful. All right, some inequalities. Beautiful. 2x plus 6y is less than 18. Graph it. So I'm going to subtract 2x, so I will have 6y equals negative 2x plus 18. Divide by 6, divide by 6. I'll find that y equals negative 1/3 x plus 3. So y-intercept of 3 is slope of negative 1/3. Down 1, right 3, down 1, right 3, up 1, left 3, 1, left 3. Solid or dashed line? Well, since this is strictly less than, this will be a dashed line. And then remember, shading is essential. If I plug in 0 for x and y, I get 0 plus 0 is less than 18. Is 0 less than 18? Indeed it is. So I will shade towards 0, 0, which means I will be shading this section here. Beautiful. All right, number 5, a system. So we got a couple things here. First, I see that y is less than or equal to 7. I'm going to do that one first. A solid line, horizontal, 7, and I'm going below there. Less than or equal to. All right. So 2x plus 3y is greater than or equal to 9. So 2x plus 3y equals 9. We can subtract. 3y will equal negative 2x plus 9. Divide by 3. Y will equal negative 2/3 x plus 3. 3 is right here. Up 2, right. Oh, wait, negative 2/3. So we'll go down 2, right 3. Down 2, right 3. Down 2, right 3. Up 2, left 3. Up 2, left 3. 3 solid or dashed line for this one. Since this is greater than or equal to, we'll have a solid line. Go ahead and draw that like so. Okay. When I plug in 0, is 0 greater than or equal to 9? No, it is not. So that means I will be shading away from 0, 0, which means this will be going up and to the right of the line. Now my other one here, 4x plus y, is less than 6. So I'll say 4x plus y equals 6, which means y equals negative 4x plus 6 when I subtract 4x from both sides. So plus 6 would be right here. And this will go down 4, right 1, down 4, right 1, down 4, right 1, down 4, right 1, up 4, left 1. Very good. Dash line on this one because it's strictly less than. So a dash line. Try to connect these dots here. Okay, and when I plug in 0, do I get a true or false statement? 0 is less than 6. That is true. So that means this dash line will shade towards 0, 0. So looking at the overlap section, I need to be below y equals 7, and then between these two, so it's going to be this little triangle right here. That would be my shaded region. We can have some fun, I suppose. I wonder. Let's make this not too thick. There we go. Shade it in like so. Try to have a little more fun than normal. There we go. Go Chiefs. I don't know why it turned out red and yellow, but it did. Alright. Number 6. For problem 6, use this matrix. A, what is the order? Remember, order is row by column, so 3 rows by 4 columns. 3 by 4 matrix. What's the value of 2, 3? So remember, this is telling us row 2 and column 3. So what number is row 2, column 3? 2. And that's it. Write the entries of a 4 by 4 identity matrix. Oh, of course, the identity matrix. So 4 by 4, remember, is zeros everywhere and ones on the main diagonal. And there's a 4 by 4 identity matrix. If A is this and B is this, will AB equal BA? Ah, great question. So remember multiplying. We need the orders to match. 3 by 3 by a 2 by 3. Remember, these inside numbers need to be the same. So will AB equal BA? No. AB is not possible. Remember that multiplication, the order matters when we're multiplying matrices. So we can get BA. Right, so this would be AB. BA would be a 2 by 3 by a 3 by 3. These are the same. So they would be able to be multiplied, but AB is not because the columns of A does not match the number of rows in B. So AB is not possible. All right, number 9. Using this equation here, find the values of x and y. Cool. So remember, when you see something like this, the first thing you got to think of, okay, I got to solve one variable first. So notice that this top right term is the only one that only has one variable, and it's going to be equivalent to the other top right term. So the first thing I'm going to figure out is what x is. So negative 3x equals negative 12. Divide by negative 3, divide by negative 3, and I find that x equals 4. Okay, so now that I know x is 4, I can pick any of these to plug in. I see this one here, x plus 3y. So that would be easy to just plug in 4 plus 3y equals 2. And I got that 2, of course, from here because I'm in my bottom left here, so bottom left here. So I need to just subtract 2. Subtract 4. What am I doing? Subtract 4 from both sides. So, let's see, subtract 4, I get 3y equals negative 2, and then divide by 3, and I find that y equals negative 2/3. Now remember, we're not writing this as a coordinate. These are two separate values for variables, not a coordinate pair. We're just finding what x and y equals. Excellent. All right, 10 through 12, simplify if possible. Okay, number 10, we're multiplying some matrices by a constant and then adding them together. Awesome. Let's do the multiplication first. Remember, we just multiply every term in the matrix by that constant. So we're going to have negative 2, negative 8, 4, negative 6, 4, negative 2, negative 10, 0, 8, plus, now let's do the second one. So multiply all these by 3. So 9, 0, 3. negative 12, negative 6, 3, 18, negative 9, 18. And we'll add it up here. So remember to add, we just add the terms in the same spots. So negative 2 plus 9 is 7. Negative 8 plus 0 is negative 8. 4 plus 3 is 7. Negative 6 plus negative 12 is negative 18. 4 plus negative 6 is negative 2. Negative 2 plus 3 is 1. Negative 10 plus 18 is 8. 0 plus negative 9 is negative 9. 8 plus 18 is 26. And there we go. Beautiful. That right there would be our answer. Number 11. Okay, so let's see if this, we're multiplying. So let's see if that's possible. We have a 3 by 2 by a 2 by 3. Notice how these are the same, so it is indeed possible. Okay, so let's try to pull up our calculator here. So we're going to have to input a couple matrix. So let's do this first one. It is a 3 by 2 matrix of 2, negative 1, 4, 2, negative 3, and 1. 2, negative 1, 4, 2, negative 3, 1. Excellent. And let's do matrix B here, which is a 2 by 3. 3 of 3, 0, 5, negative 1. Oh, I hit negative 2. Always got to be careful here. Negative 1, 2, negative 3. Got to be sure we input the correct values. So second quit, second matrix, I'm going to do A times B and press enter. And here is that 3 by 3 matrix that would get, right? Number of rows from A, columns from B. So this is going to equal, oh goodness, what have I done? Let's scoot it back down here. So we're going to have 7, negative 2, 13, 10, 4, 14, negative 10, 2, negative 18. Beautiful. All right, well, that is our answer for 11. Let's look at 12. Oh, yes, let's look at 12. So notice 12 is a 2 by 2 by a 3 by 2. The inside numbers do not match. So this one we would just say not possible. Can't do it. All right, number 13, write the matrix equation equivalent to this system. Okay, matrix equation. Remember what that looked like. We talked about that at the beginning of this unit and then really never mentioned it again. So if we need a refresher, that's okay. Remember, this is the one with multiple matrices in the equation. So the first matrix is the coefficients. So 4, negative 3, 7, 1, 0, 3, 4, negative 7, 0. Then the next matrix is one column of variables, x, y, z. And the last one is the coefficient. So negative 14, negative 12, and 14. There we go. That is the matrix equation. I feel like there's always a question like this one that people almost always just write the augmented matrix. Be sure to write the matrix equation. All right, 14. Perform the indicated row operations and write the new matrix. So this is a different format than what we've seen. This is the format that's been used on the test the past couple years. I don't know what the format will be on this test, but if you see something that looks like this, what it's saying is here's our original matrix. We want to replace this row with this, and we want to replace the bottom row with this. Whatever's next to it is what we're replacing it with. So what it tells me here is I'm not changing the top row. So that's good to know. So I'm going to create my final answer over here. So the top row is still going to be 1, negative 2, 3, 5. Now to find the second row, I need to do negative 2 times R1 minus R2. So negative 2 times R1 would be negative 2, 4, negative 6, negative 10, and then I'm going to subtract R1, or R2, excuse me, which is 3, 1, negative 2, negative 3. Not that I would ever subtract R2. I think, R2 might actually be the hero of Star Wars. So negative 2 minus 3 is negative 5. 4 minus 1 is 3. Negative 6 minus negative 2 becomes negative 6 plus 2, which is negative 4. Negative 10 minus negative 3 will become negative 10 plus 3, which is negative 7. So we will have negative 5, 3, negative 4, negative 7. So that's R2. Let's do the same thing now for R3 here, which is going to be 3R times R1 plus R3. So I'm going to multiply R1 times 3, so that gives me 3, negative 6, 9, 15, and then I'm going to add to it 0, 4, 3, 1, R3 there. So 3 plus 0 is 0, 3 plus 0 is 3, negative 6 plus 4 is negative 2, 9 plus 3 is 12, 15 plus 1 is 16. So I would have 3, negative 2, 12, 16. Beautiful. There we go. All right. So that right here is my final answer with those row operations. All right, last problem here, number 15. 50,000 was borrowed in 3 loans at 6%, 7%, 9%. The annual interest rate was $3,650. If the amount invested at 6% is $1,000 more than twice as much as was borrowed at 7%, how much was borrowed at each rate? All right, so first thing I'm going to do is I'm going to add together the amount from the 3 accounts. So if I say x plus y plus z equals the amount invested, which was 50,000. And then I can do the interest rate of each. So 0.06 of x plus 0.07 of y plus 0.09 of z equals the amount we got from interest, 3,650. Now this last equation, the amount invested at 6%, which is shown here as x, is 1,000 more than twice as much was borrowed at 7, so that'd be 2 times y. So if I double y and add 1,000 more, I will get x, right? It's 1,000 more than twice as much was borrowed at 7. Yeah. Okay, so to get this into the form I want, I would be x minus 2y equals 1,000. So we'd say x minus 2y equals 1,000. There we go. Okay, let's create a matrix here. So we're going to have, oh boy, hello. Let's try that again. We're going to have 1, 1, 1, 50,000, 0.06, 0.07, 0.09, 3,650, and 1, negative 2, 0, 1,000. And then that we can put into our calculator, RREF. When I do that, I can go to my matrix. I'm going to edit matrix A, make it a 3 by 4 of 1, 1, 1, 50,000, and then 0.06, 0.07, 0.09, 3,650, and then 1, negative 2, 0, and 1,000. Excellent. And second matrix, go over to math. We're going to RREF it. Second matrix A, close parentheses. Okay, so we get 1, 0, 0, 21, 500, 0, 1, 0, 10, 250, 0, 0, 1, 18, 250. All right. So remember, x is my amount at 6%, y is my amount at 7%, z is my amount at 9%. So for the context of my answer here, I would say 21,500 at 6%, 10,250 at 7%, and 18,250 at the 9%. And that tells us how much was invested at each rate. There we go. All right, and that's it. There is our Unit 5 practice exam. Hopefully y'all are feeling confident about that. If you haven't already, then go ahead and look at the take-home portion of the Unit 5 exam if it's available. And go ahead and get started on that. Let me know if you have any questions. I'm here to help. Feel free. I'm just an email away. All right, this is Mr. Carter signing off. I will see you next time.